My name's John. I'm excited to be here. I know some of you that are on the call. I work at Microsoft as a CSA, and all that really means is that I go and hang out with customers who are trying to do work in Azure and help them have a good experience. And for one reason or the other, identity work always seems to roll downhill, and I can't get out of the way fast enough, so I end up doing a lot of it. And so over the course of time, we've come across lots of different environments that customers have and lots of different things that they need to modernize. And so we thought it'd be a great idea to at least start talking about how to think about it. And then we'll look at how we take an app from something like on-prem AD or even something that's even older like a ColdFusion app and get that up and ready to use with Azure AD. So depending on which side of the Twitter war you fall on, this could be the last call of the decade, or it could be the last call of the year. I'm not sure which one. Some people say 2019 is the end of the decade. I guess other people think it's 2020. Anyways, we're going to talk about how we plan and evaluate our moves and why we would want to move in the first place. And then we'll look at what I like to call the continuum of migration, right? And this is really similar to any other type of cloud migration, which is there's a great starting point, and there are lots of interim steps before you get to sort of the top end best place to be for deploying your stuff. But you may find that it's not worth it to go all the way up the ladder. You may find that it's not worth the time, the effort, the dev work, the money involved in getting all the way to the top. And so you may find a place that's somewhere in the middle that makes more sense for your applications. And so we're going to look at what that spectrum looks like, but just know that not every app is a great candidate for going all the way to the far right. There are plenty of apps that fall in the middle, and I'd say the majority of them do, unless they're new dev or they're the one thing that makes your business money. There's certainly going to be some cost trade-off there and some time trade-off, and we'll look at what that looks like. And then after we get there, we're going to dig into some code, and we'll take a look at the stages that we take an app through to help modernize it. If there are any questions, comments, concerns, personal attacks, put them in the chat, and we'll try to either catch them as they come, or we'll have some time at the end for Q&A. So buckle up and let's go, right? So the first thing we want to look at is why we'd even want to consider migrating, right? And there are a whole host of different reasons, just like when you migrate anything else to the cloud. There are a whole host of reasons why you'd want to migrate to a more modern identity platform, besides just a very controlled on-premises environment. The first one that we have to get out of the way is, of course, if you have a username and password database today, you now have a giant target on your back, and everyone's going to be out there trying to find it. But I think some of the other things that go without saying, or things that don't normally get brought up, are around how you can enhance your applications, right? You want to add in new functionality with different partners like us. So if you want to add functionality to your application to, say, save some files to OneDrive or send an email as a user, or connect up APIs that are protected into things like Microsoft Flow or Power Platform, we need to be a part of this new modern auth ecosystem, and we want to make sure that we're offering this sort of progressive enhancement to our customers of how we make our apps better by connecting to more and more of the services that they use, right? But there are lots of other scenarios, things like mergers and acquisitions, where we've picked up a new customer or we've picked up a new company and they have an existing very old or crusty or super complex identity system, and we need to get them into our applications quickly, right? We want to get them integrated faster and not have to keep these two services on into perpetuity, right? We need to get them into our services and authenticate them in one single place, as opposed to having to have lots of multiple username and password or dual head type scenarios that we're putting our employees through. So the first thing we want to look at is planning and evaluation of how we're going to both plan our migration, because of course those migrations are 90% planning and 10% execution, but then also what kinds of apps make the most sense, right? So the very first thing is, if you have a password database, then we need to get rid of it, because lots of people thought that they could do password databases correctly, and we probably don't necessarily want to go to the same route that they did, right? If we go look at what's out on haveibeenpwned.com as of a few days ago, there are over 9 billion accounts that are out there, usernames, passwords, etc. It's been in the news recently about ring.com, and people accessing their home cameras and talking to their children and saying really awful things. And they've built systems that are specifically for running through lots of credentials, lots of stolen credentials at Ring. They've built tools specifically for doing that, because Ring doesn't have any real credential protection or login protection as a way to keep people from just hammering their endpoints with different usernames and passwords, or making sure that somebody's not signing in from the far east and the far west at the very same time, right? So if you have a password database today that runs your application, we want to look at getting out of there as soon as humanly possible. The next big thing we want to think about is who's going to be using our app. We all have different suites of applications, I would imagine, that we all have to own and manage. But typically, we see them fall into these three big buckets, right? So we have internal ones that are purely internal users. These are people, corporate users who are employees at your company or have some sort of a relationship with your company where they work for you. Those types of apps are relatively straightforward for us to integrate, right? If you're using AD on-prem today, and we look at using Azure AD tomorrow, that migration path is relatively straightforward. Not that it doesn't have its complexities, but in terms of the cognitive load of figuring out what does it take to go from AD to Azure AD, it's relatively straightforward. Where we start to see more complexity is in these mixed environments. I'm sure everyone who's on the phone, or at least has worked with some people who know, directories and ADs that are sitting on-prem that have tons and tons of external directory, or tons and tons of external users in there. And these are vendors, they're partners, they're people who have a quasi-business relationship with our company, and they need to use the tools, the systems that we have, but they don't necessarily work for us, and thus they don't have a proper sort of corp account. So we give them a proper corp account. We give them an account, which is another username and password for them to remember, which is inevitably written on a Post-it note and stuck to the corner somewhere. We give them a username and password that gives them an AD account, right? It sits in our directory, and now we have to manage the life cycle of that. Now we have to figure out, oh, well, you've left your actual company, but we have no idea that you've left, and so you could come back and sign in with these AD credentials that we gave you 6 months ago and access all of our systems, even though you don't work for your parent company anymore. And of course, that gets much riskier when we look at things like malicious insiders and people who are trying to exfiltrate data before they leave. And in order to stay on top of that, there's a whole lot of extra work that you and your identity teams have to do to keep that governance at a high level, right? We either have to inconvenience people, the users, by changing their passwords every so many days or requiring them to revalidate that they still work for their partner, or we have to have some sort of external process where the partners say, hey, Carl doesn't work for us anymore, so you need to make sure and delete his account. And all of those things are overhead, right? Some of that's solved by using things like ADFS, where people they have federation partnerships with us, and we've connected our organizations together, but now we have individual federation partnerships that we have to manage. It's certainly better than just giving people new accounts, but there's still additional things to manage, and it's a very point-to-point relationship. So I have a relationship with company A, and so I go and add company A's federation data into my ADFS or whatever sort of external STS you're using, and now I have to own and manage that myself. And so we have to keep on top of what that partnership looks like. We have to keep on top of what types of claims transformations we have to build. And each one of those largely is individualized per partner. So for every single one of our partners, we have to go and make sure what their incoming data looks like makes sense to us, and then parse it out and get it into something that's more, that matches our sort of the identity schema that we're expecting. And then, of course, depending on your apps, that could add additional complexity, right? Because you've got to trust users coming from your AD, you've got to trust users who are coming in via claims with ADFS, or potentially coming in directly from a direct federation partnership right in with your app. So it cranks up the dev complexity, not necessarily something that you want to write, certainly not something that I want to write. And so while ADFS helps, it certainly isn't the silver bullet that we'd all like for it to be. And then on the last side, we have the external customers, right? These are customers of ours who are using services that we're delivering to them, or who are logging in to manipulate their accounts or manage their services that they're buying from us. Those are stored in all sorts of different repositories, but almost all of them end up having password databases at the end of the day too, right? If you want to do social integration, you end up manually configuring apps in Facebook or in Google or wherever, and then your app has to handle those OAuth and OpenID transactions with those external partners. And so again, it cranks up the complexity within your application, but it also means that you have more and more you have more and more of these partnerships that you have to manage and code against. The next question we need to ask ourselves is what type of services we need to access, right? And so if you're not accessing any of our services, any Microsoft services, and that makes us sad because obviously we'd like for you to use more of ours, but if you're not accessing any of our services for your apps, then Azure AD and B2C are both really easy and straightforward to get moving, to get migrated over to. If you need to access your own services, so if you're delivering a service or if they're internal, Azure AD services or internal Office 365 services for your corporation, then Azure AD Normal and B2B become options that we can consider there, right? I was hesitant to put B2B on here because inevitably lots of people try to use B2B for things that it wasn't really made for, and so they end up getting in a lot of trouble later on down the road, but we'll talk about that in a minute. And then our last one would be if you need to manipulate your customers' Microsoft services. So if you want to give them a save to OneDrive button, if you want to give them some sort of extra functionality, then that's when we look at things like B2C and Azure AD Multitenancy, right? Because at this point, we're now going to be delegating all that sort of identity management off to our customers anyway. And I'd say that the majority of the customers that I work with, that's what they want, right? If they're a software company who's delivering a service to their customers, that's what they want, right? For software distribution, when we're selling software to customers for them to use, software as a service, that's one of the big pieces for Azure AD Multitenancy. We have a customer that's a large sort of retail financial type of company, and they sell a lot of the data services and reporting around their the hardware that they've sold to their customers as software as a service, right? So they own all of the servers that are running it. Nothing runs on-prem outside of the physical hardware itself, but all of the software that's running is running in the cloud. And so they need to distribute that out to their customers, and they want their customers to deal with who has access to it, who can do what within there, right? So I give my admin access, or we onboard customer ABC, and customer ABC's admin knows, Carl in accounting needs this level of access, and so he assigns that or she assigns that as the customer's Azure AD administrator rather than as the company that's delivering the software to that company. If you also need to include your customers, in addition to that sort of Azure AD multi-tenancy type space, that's when we're looking at using a combination of Azure AD multi-tenancy in addition to B2C. In some cases, we can launder those users through B2C, right? So then your application trusts a single endpoint, which is B2C, and all of your identities are coming through B2C regardless of where they actually started from, right? There are some trade-offs to doing that. Most notably, the biggest one right now would be that any Azure AD multi-tenant user that flows through your B2C now becomes a monthly active user in B2C unless you have to pay for them. But now we're talking about shifting cost to manage dev complexity, because an application that trusts a single identity system like B2C has a much simpler sort of development overhead than an application that has to trust multiple identity providers, right? And then, of course, in the last one, for apps that are primarily external users, B2C is sort of your first choice. Inevitably, there are lots of internal users who may need to use those apps either for administration or for managing who has rights to what, or for onboarding new customers. And so again, we'd say, well, let's launder those customers into B2C, right? That way our application is still trusting a single point, right? Depending on the kinds of services that you need from us, if you want to enhance your applications with some of our services like Graph or Exchange Online or Office 365, that's when we look at using things like multi-tenancy. Because multi-tenancy is going to let us request those types of permissions from our customers' tenancies, right? So if I need to send mail as a user of my application, then I may want to do that via multi-tenancy, right? Instead of having to deal with and manage an email system on my own, since we're manipulating a user's mailbox anyway, and we want to send mail as them, then let's go ahead and do that, right? So anytime that you need to use one of your customer services, you're almost always looking at Azure AD multi-tenancy. B2C doesn't let you do that, right? So B2C itself doesn't have any access back to Azure AD proper, in the sense that I can't access your mailbox or request to access your mailbox if you're signing in with B2C. There are some ways around it for things like passing through access tokens, for example, with B2C, which is a great step in the right direction for making those kind of scenarios happen. But what it ultimately means is that it's an enhancement, right? It's not a hard dependency, because if it was a hard dependency, then we would just use multi-tenancy to start with, if we absolutely have to access Microsoft services in order for our application to work. The next thing is who owns those identities. And a lot of this goes back to what we just talked about, which is who actually is in control of that identity and who ultimately needs to own and manage it. And when it's you take on the responsibility of dealing with that. And a lot of that you do via your Azure AD admin. So once we've moved over to Azure AD, your administrators are going to handle the lifecycle of those accounts. They're going to handle conditional access and what sort of changes and what sort of policies need to be in place for people to log in and use things. And so you can sort of share the load a little bit across you and your operations, your identity teams. When someone else owns your identities or owns the identities that you need in your application, each one of these types of things here adds complexity. And so by using something like Azure AD or B2C, we can put the complexity there and keep the complexity out of our application. So we look at the technical side of what we're actually talking about doing. Right? If we have a piece of software, we've got a web app and it uses SQL or it uses something else that's sitting on-prem, we need to think about what kind of technical dependencies we have, right? So if I have a piece of software, a web app that's running today, and it's running on IIS, and it's domain joined, and I have a Windows integrated authentication turned on IIS, and then there's an Active Directory environment around it, I can't take that app out and put it anywhere else. Right, I lose that ability without going and changing code in order for me to support some alternative method, right? Some alternative method of authentication. And the reason for that, of course, is that AD and Kerberos all have a lot of workstation server trust built into them. So there are a lot of things that are happening outside the scope of your application. So your app looks and says, oh, well, user.identity.name, for example, in .NET, well, it's just there because somebody's configured my server correctly. And so in some ways, because I've done .NET now for like 15 years, in some ways, I guess we all got kind of lazy in .NET because we were like, oh, well, I mean, obviously we're intranet and we're on-prem and we've got AD and everything around us. So yeah, I mean, this is super easy. I don't even know what happens. All I know is that user.identity.name returns me a name, and so I can go and use it, right? And now we can still get to that pretty close, at least, to that ease and that sort of simplicity of development. It's just that a lot more of the interaction that's happening is happening through the browser. It's happening over HTTP instead of happening via the server back channel back over to your AD domain controllers or whatever. And so because of that, I think it gets a little bit intimidating, and there are lots of different things that could go wrong during that exchange. And so I think for a lot of people still arm's distance away from identity, a lot of developers don't necessarily want to dig in too deep on it because for the most part, it's always been handled by someone else, right? It's always been handled by an ops team or someone similar. But it's important to keep in mind that anything that's happening outside of the scope of your application that's influencing your identity decisions and influencing your authorization decisions, those are all things that we need to catalog before we start thinking about moving these apps, right? So this specific example uses Windows Integrated Auth, so just an AD, typical AD directory and environment. But you could have HTTP modules that are running in IIS for things like SiteMinder, and then we need to know about those too. And so cataloging what those external dependencies look like is super important, and one of the probably one of the most enlightening behaviors you can go through to find out all the different pieces that have been set up that are around your app, but they'll also help tremendously in getting the app actually where it needs to be. So the last big question is around what type of dependencies you have on the identity service, right? Things like querying LDAP, things like using impersonation, things like service accounts, which we're going to talk about in just a minute. For the most part, we have cloud or Azure AD analogs that are very similar to these, but they do require code changes, right? So if you're making an LDAP query today, tomorrow we're going to need to query against the graph, right? Some of those queries and the structure of those queries is going to be different, because things like OUs wouldn't necessarily exist in the graph, right? So depending on how you're granting people access, what types of queries you're doing, what types of extension attributes you have, if that's what you're using for making authorization decisions, then we need to, again, catalog those and know what they are, because those are going to have to change, right? Service accounts is probably one of the biggest ones. And I think part of that's because service accounts on-prem and service accounts in cloud with service principals, they don't really have a good feature mapping back and forth between each other. So if you look at service accounts on-prem, it's effectively just another account, right? Now, there are managed service accounts, managed SPNs, that sort of thing. But ultimately, they tend to end up being just another account that somebody's created. In later years, when we had the managed ones, they were a little bit easier to deal with. But for authorizing service accounts to do things on-prem, we would put them in specific groups, or we would treat them just like a user and put them in the right place, or add the right attributes in order for us to control what it is that they had access to. In Azure AD, when we look at using service principals, because we don't have a user in the case of a service account, if we've got some background service, because we don't have a user, we have to use an application permission if we need to use certain parts of the graph. And one of the most popular or common ones that comes up is, I need to send mail from my application. I need to send a notification to a user. I need to receive a mail from a user, whatever. The problem is that you'll notice all of these permissions that are up here right now for mail are all things like read mail in all mailboxes or read basic mail in all mailboxes. And that's a pretty broad amount of access that most admins would be pretty uncomfortable granting, right? And in most cases, your application doesn't need to read all mailboxes. It needs to read one mailbox, or it needs to send mail from one mailbox, not from all 150,000 of them in your org. And so for right now, the way we look at doing this is sort of twofold. So we have the scopes. We have these scopes that we've granted our applications to request, and then each individual upstream service is required to have an additional layer of authorization that lives on top of it. In the case of, say, Exchange Online has something called access policy. Access policies are assigned to service principals in Azure AD. And so now I still need to be able to send mail as any user to Azure AD. But then Exchange Online says, oh, wait, I know who you are. Yeah, you can send mail, but only from the accounts that are mapped in this specific access policy. Your apps follow a similar model. You can publish scopes, and those scopes can be as coarse or as granular as you'd like for them to be within your app. However, you're still on the hook for both enforcing what the scopes can do, and then if you need more granular permission than what you've elected to publish into your directory, there's still sort of a second layer of authorization that needs to happen. And so I only bring this up because the service account part specifically is something that we see a lot of customers struggling with pretty frequently around making sure the permissions are exactly the ones that they need, but not being overly broad. And lastly, identities team support. There are lots of people in your org who are all interested in identity, and lots of people will have opinions. Some of them may want to be accountable for those opinions, but identity is one of the few things that really touches every part of the business and that everyone will have a say in, right? Your business teams know how they need to authenticate users, or they know how they want users and user acquisition to look like. They know what those user experiences are that they want and the types of things that they want to enable. Legal has their own requirements around how we store data, how we manipulate it, the right to be forgotten, a guaranteed deletion, those sorts of things. And then, of course, your ops and engineering teams have to build against those requirements. And figuring out if ops is going to do it, figuring out if engineering is going to do it, or figuring out what that marriage looks like between the two of them is super, super important, because we don't want anyone to be on the hook where ops is saying, well, no, we're not going to do this. And now your entire software project is put on hold because you can't get the right permissions that you need. We've got an example right now with a customer who's 6 months delayed on their software rollout because they can't get the permissions that they need from an Azure AD from ops, and rightfully so, because the permission set that they've requested is considerably too broad, right, and puts the organization at risk. So working together with all of your stakeholders early on, just like you would in any sort of normal software project, is super, super critical here. because again, everyone's going to have an opinion, and there are going to be lots of the flow chart for these types of decisions is very wide and very deep, right? So we want to make sure that all the people who are involved in this are get in and get in early. Okay, so then we're going to jump into what to actually do, like the how of how we're actually going to start doing some of this work. So one of the first things we have to figure out is where all of our identities come from, right? So after we've gone through our evaluation, we figured out, oh, we've got identities that are coming from 7 different systems, CRM and ERP and some external customer side and then some external databases or whatever they are. Ideally, we want to centralize to something on-prem first, right? In the case of Azure AD, those users need to be synchronized to Azure AD from some sort of on-prem store to begin with, or some type of a store. It doesn't necessarily have to be on-prem, but some type of a store is what fills Azure AD with all those identities. If you're using Office 365, of course, you already have Azure AD, and so chances are you're synchronizing identities from your on-prem, AD or whatever that might be. But using tools like MIM or FIM or MIS or whatever the name du jour is, and consolidating identities with all the right pieces before you launch them into the cloud is a very good strategy for simplification before you even get cloud side, right? Because all the complexity it might take to get your identities into one place, once it's in Azure AD, your application doesn't care because all it sees is Azure AD, and that's what it goes and uses. In the case where you're using federation with multiple different partners, it may be time to evaluate if multi-tenancy in Azure AD is the right move, is the right path. If all of your customers are mutual customers of ours and they have Azure AD and Office 365, then with multi-tenancy we can start to shut down some of those federation partnerships depending on the complexity of them. If they're not mutual customers, maybe we look at using B2C. B2C being the way for us to pull users in from a myriad of different sources, being able to get them closer to this sort of centralized identity place before our applications go and start to use them. And then the last one, if you have a username and password database, then you should go directly to B2C. Use JIT migration, which is a pretty well-vetted pattern. We've got some code samples and things published out for doing JIT migration in B2C. We want to get away from that as quickly as possible, right? We want to get away from storing a database that has usernames and passwords as quickly as we can. And with JIT migration, instead of having to do a sort of a massive forklift all at one time, instead, as users sign into the old system, we can migrate them into the new one and then put sort of a time box around it and say, okay, well, in 6 months, we're going to shut off our on-prem internal database, and we're going to be moving forward with nothing but B2C. And then lastly, these are our last steps, right before we jump into what the migrations actually look like. The first one is you need to know where you're going to go. So what's the output of all of your sort of evaluation? Are we going to go to Azure AD because it's an internal app? Are we going to go to multi-tenancy? Are we going to use B2C? Making sure we keep in mind all those external dependencies we might have, either Office dependencies, service dependencies, or via or on-prem dependencies with things like service accounts or specific schema extensions and what those look like. Who's going to do the work? Who's going to own this ongoing, right? If dev owns it, their application complexity may be a little bit higher, but if they own it, that's for them to own sort of into the future, right? So the ongoing maintenance of that code is something we have to really consider. In addition, if there are many, many different apps, do we want to ship that same code into every one of those apps? Or do we want to have our ops team sort of centrally managing those identities and writing code in a different way, right? But either through things like B2C custom policies or through automation and management of the Azure AD tenants. That's a decision for you and for your org, for where the maturity lives in your org and for who ultimately should own that, either through the sort of business rules of who's going to be maintaining those relationships, or just the technical side of who's got the talent, the bandwidth, and the budget to go and own that. And then lastly, your existing authorization data. If you have existing authorization data in something like a database, which we're going to look at here in a few minutes, if you have existing authorization data, that needs to be available, right? You may want to keep that in your apps database especially if it's very specific to your application, right? And by authorization data, I mean what role is a user in or what permissions do they have within your application, not necessarily their specific PII of their name and email address and that sort of data, but an opaque identifier that is tied to them that confers them specific rights or abilities to do things within the app. So our migration path. So, of course, like we just talked about, we want to centralize our identity source system. Next, we want to look at migrating from our on-prem authentication type of story into our new modern system, right? So we've got primarily OpenID Connect and OAuth 2. Those are going to be our really big ones that we look at for authentication in Azure AD, because largely that's what we support, and that's what the vast majority of the public identity systems support. We can support things like SAML and some of these older standards, but if we're migrating our applications and we're actually going to go and write code to do it, then we want to make sure that we're writing against something that's relatively the best of what we can do for right now, right? Then we move into authorization, and authorization is sort of authorization. There's a threshold where some authorization data may live inside of Azure AD, and some authorization data may still live in your database. The threshold for where that data should live is really if it's pertinent outside of the scope of your app, maybe it makes more sense to live in Azure AD or be a part of the graph, as opposed to being stored just in your app, and then it has to be synchronized to other apps if it's relevant to those other apps. But conversely, if there are pieces of authorization data that you need that are only really relevant within your application, or if they're super, super complex, that might make more sense to stay within your app, especially if it's old and sort of grown over time, and you can't really express those types of authorization rules in things like groups and roles. Further up the chain, we get into integration with external partners, either you using our services or letting other parties use your services, right? Shared data model, where we have lots of different pieces of data that are all available about our users within our org, and we want any of our developers to be able to tap into that and use that, right? Or we have external partners who want access to some of our data, and we want to let that happen. There are plenty of cases where people share credentials today, right? Where, we've gotten a shared account for some third-party SaaS vendor, and just everybody goes and grabs it, and that's the one that we use. If you want to offer those types of services to your developers, to your customers, where they can connect in, we start to get a little bit more complex in how we're managing our APIs then, and how we're designing the software around them. But we start to open up all sorts of new scenarios for things that we couldn't do before, right? Or things that were dangerous to do, before. There are two primary sort of tactical patterns, if you want to think about it. Of course, we have direct integration where you just write code. We're gonna refactor our apps to start using these new identity systems. But one thing that we haven't really touched on yet so far is around apps that are really old, or so old that the platforms aren't supported anymore. They're vendor software that we've purchased where the vendor doesn't exist anymore and can't update it, or it's just so the domain knowledge around how it works is just unavailable within the org because people have left, retired, etc. This happens, I think, more frequently than anybody would like to admit. And so for that, we look at proxying. In America, we have this thing where people go to sports games and people will launch T-shirts and things at them. That's sort of how I think of the proxy method, where in effect we are sort of barricading our app behind lots of network ACLs, and then there's only one front door to get through, and we're going to start launching data back and forth between that app into these two sort of landing zones. We've got our app on the inside, and we've got whatever our proxy is going to be on the outside. And so on the proxy side, we've actually done this with a couple older apps, right? Primarily, there's one that was specifically ColdFusion, and at the org in question, there really wasn't anything that existed for them to use. There were no sort of pre-baked libraries or anything because the version of ColdFusion they were using was so old. And most of the both technical and domain knowledge around how to use ColdFusion within that business a lot of the people had left. They'd either retired or they'd moved on. And so they were left with a group of developers who really weren't that familiar with ColdFusion, certainly weren't interested in implementing their own view of the OpenID or OAuth spec into ColdFusion. And so this became somewhat of a viable alternative. We have other systems where customers have really old IAM systems, and authentication for them is happening in an out-of-band process where a specific set of headers are added to the requests, and the headers themselves are largely unprotected. So once the application receives the headers, the application reads the headers and says, oh, you must be user ID ABC, so here's the data that user ID ABC is granted access to. And so a lot of that's happening with things like SiteMinder, where there's an HTTP module that runs an IIS and handles that communication back and forth. And so in those types of scenarios, this works too, where if we're really just trying to get down to a set of headers that are available on the request, we can handle that upstream and then pass that along downstream to the app itself, as long as we've sort of fortified the wall around that app so that nobody can just jump right in with the right set of headers, right? So then it comes down to network ACLs and the like. And we've got one of these that's published that anyone can go out and grab, that's out there on GitHub, and we'll share some links for the deck and everything else at the end. But a reverse proxy with Apache mod rewrite, where Apache itself is handling the JWT and OpenID interaction, redirecting the user, consuming the tokens, getting new ones, and then forwarding that data back on to the backend app, depending on how the app needs to consume it. In this case, it needed to consume it with an arbitrary header name. So we were taking some of these claims and pivoting them into a new header name, and then pushing that downstream to the app. What I would expect would be more common among this audience is going to be directly writing code against your identity system. This is actually some newer ColdFusion code, which no, we're not going to write today. But this is actually some newer ColdFusion code that does support at least OAuth 2. And you'll notice this is a really naive, really quick and dirty OAuth 2 implementation to use OAuth with Azure AD within ColdFusion. So I'm going to jump over and we're going to take a look at a little bit of code. Let me stop, and the code for all this will be available. It's all available out on GitHub, so no problem there.
I posted a question in the chat there. So my question was about app registrations and how do you categorize them? So you have multiple landscapes, dev, test, prod. Do you create a separate app registration for each of those landscapes, or do you just distribute client secrets named with the landscape so you know which one it applies to? And then the second part of app registration question is do you make separate app registrations for delegated versus application permission situation?
So I address the second one first because I think that's probably a shorter answer. I've yet to see that in any sort of broad practice where we have one set of app registrations that have delegated perms and the other one have application only. Typically, we see that where there are two maybe components of the same app. There's a backend, queue processor or backend processor that has its own app registration, and all it's doing are application level pieces. In which case, there are separate ones in that way. But as far as the same physical application, like the same web app, for example, I haven't seen that, and I think there'd be some issues. I'm trying to think of the best way that you would even actually accomplish that outside of having sort of two application identifiers within the STS.
Yeah, I think that's true. This is really, actually it is a WordPress, it's like an internal corporate site. It's kind of described the way you said the first time. So it's one plugin is doing some application permissions, and this other plugin is just doing delegated permissions to the graph. So essentially, it's kind of how you describe.
Okay, then yeah, I think in that case, you'd want the isolation to be there, right? Because you're kicking off between two different processes, and one process is super privileged and one is not at all, or lesser privileged, I guess. And so two separate app registrations would absolutely work in that case.
Sounds good, thanks.
And then the other side around environments, typically we see, or at least in my own experience, I see customers with a set of lower, like all the lower environments might share a single app registration. Depends on the what permissions those app registrations need. Typically, if it's just login and they're not doing a whole lot of graph work, typically we see one for lower environments for dev, QA, tests, and then we'll see a separate one that's managed separately and typically with a stronger credential like a certificate rather than just a string secret being used in production. And typically those are managed by, they have different sort of governance rules around them. Some customers go so far as to have multiple Azure AD tenants. That gets to be a bit messy and a little bit difficult to manage. But having separate registrations, I don't know if you need to go so far as to have one for each environment, but at least the segmentation between lower environment and production environment, that seems to be a pretty common pattern and certainly helps with sort of the ongoing life cycle of those secrets for those apps.
Thanks.
Sure. Any other questions? So really briefly, I've got a repo that's out on GitHub, and we'll share the URL at the end of this here, but it's really sort of taking an app through a collection of different states, right? Where in this case, this app is starting with Windows integrated authentication. So it's pretty basic. There's an authentication mode here. We've enabled Windows authentication in IIS, and so we've toggled all the bits that we need to make a typical intranet application, right? So as soon as we sign in, I'm signed in. It sees who I am from the domain, and our code itself is pretty basic. There's really nothing here except for allow anonymous on certain controllers, and then we might have an authorized tag somewhere in some of our controller actions. Pretty straightforward and pretty basic here. What we see with most intranet apps. Lots of intranet apps also use groups for authorization, where you might have something like authorize and then with a specific role name or a specific set of roles, and those roles really map back into groups that are in Azure AD or that are in AD on-prem. We can do that for a short period of time as part of our migration. So maybe we do that for the first iteration. As soon as we've toggled over into using Azure AD for authentication, we want to use groups that are sent from on-prem. The thing to keep in mind is that, at least until recently, the group IDs that you'd get from Azure AD login are going to be GUIDs that map back to a name. And so we could query the graph and go and get names, but that ends up being a lot of extra work on our authentication process. And so ultimately what we really want to look at are things like app roles, where we are assigning groups or users into the app roles that are defined for your application in Azure AD. And then our app itself, they could have the same names as part of our migration so that we don't have to go in and change those sorts of things, but that the users will show up to your application with specific claims of type role, and those roles can map to those names, and then everything, quote, just works, right? And so this repository takes this app through about 5 or 6 different states. And so the first one just gets authentication wired up with Azure AD. And the only real thing that we've done here is we've added in a startup class that uses OWIN. So this is an old app. This is .NET 4.5, .NET Framework. It's not .NET Core. It's 4.5, which shipped in like Windows 7, Windows Server 2012 timeframe. So it's, or 2008 R2 timeframe. So it's relatively old. In fact, it took me an age just to make it work, like just build again in Modern Visual Studio. But we've added a new startup class. We're going to use OWIN for manipulating this. And this is really all the code that we need. There's not a whole lot to make this start working. We have to turn off Windows integrated authentication. We have to turn on anonymous at the web server level, like in IIS or wherever. But this code itself is what handles everything we need for redirecting users back and forth. We have one new controller that's also been added that just calls an HTTP authentication challenge, so that when we want to sign a user in, they click the sign in button and then they go over to Azure AD based on the configuration, and then they're sent back to us and we consume that. In our actual code, none of that changes. So authorize in this case is just any authenticated user. And all of this, quote unquote, just works, right? There's nothing special about this that we have to do. And so to move from one to the other, purely for authentication, is actually relatively straightforward. There aren't a whole lot of moving pieces. It's just primarily that we have to switch to an OWIN startup and use that for configuring OpenID Connect. If you have an existing authorization database or an existing role database, you could, of course, use that. And so now what we're doing is replacing the Windows integrated auth that we're doing at the IIS side. Now all we're doing is pulling that out and putting in a new authentication mechanism, but your authorization mechanism could still be whatever you need it to be. If it's part of a database of roles that you already have, then you can continue to use that. None of this would get in the way of that necessarily. If you're using groups in Azure AD, or sorry, groups in AD, that's when we have to look at using. That's when we have to look at using using roles that are a part of Azure AD, or using them as part of our database. The biggest change when it comes to that is that you'll notice we have this new set of notifications here, and they're security token validated. Security token validated is what happens after we've gotten your token back from Azure AD that you've signed in, and after we've validated it, and it's right before the authentication cookie gets written back in the response, right? So we have the opportunity here to add any sort of claims that we need. Now I'm just adding 2 static claims here, but you could query a database here. You could query a service, do whatever you need to do here, and then load up those additional claims into your user's object here. And as soon as this method exits, as soon as this delegate exits, your authentication cookie via ASP.NET will be written, and it will include all these claims. So now we're not constantly re-adding them on every request, for example. So this happens at login. So you're going to take a little bit of a performance penalty on logging in, hitting a database, adding some claims, but in subsequent uses within that session before that cookie expires, you won't take that hit again. In the next sort of step of complexity is when we start going and getting data from the graph to resolve those group names. Now, like I said before, this is probably not something we would recommend. It's pretty heavy. There are lots of moving parts, and there are going to be some permissions that you need in the graph to go and resolve group names that your administrators probably wouldn't want to give you. But nonetheless, this method is valid if you have group names in your code and you need to switch, and you want to switch over to getting those groups and resolving their names. This is a way to resolve the names, right? So not only do we have to deal with the authentication side, now we have to go get an access token to talk to the graph. And so here is where we're going to go and handle getting the access token from the graph via msal.net, and then calling the graph with that net new access token that we just received to go and resolve that group name. And then at the end, go and add these claims back into the claim set so that the user's claims are listed there, and we can make authorization decisions based on them. If we talked 6 months ago, I'd say this was about the only way to resolve the group names if you absolutely had to have them, but there is a preview feature now for groups that are synced from on-prem only, where you can get the group names returned in the token as opposed to the group GUIDs. So this is largely sort of if you're not in that type of a scenario, you could use something like this. And then lastly, when we're using Azure AD roles themselves, which is when we've pushed more of our configuration over into the Azure AD side of putting users into roles that we've defined for our app, you'll notice our code simplifies greatly because now we've removed the requirement to go call it to the graph. We've removed the requirement to manipulate our claim set before we issue the cookie in our app. And so our code is simplified greatly because we've pushed all the complexity of manipulating who's in what role and knowing what roles people are in into Azure AD for someone else to administer, because none of us are global admins, right? And so this app specifically, if we look at the manifest for this, all we really have to do to add this is to add in specific app roles into this manifest, and then assign users into them with the enterprise application blade, the same way that we would assign users to roles within any other apps, right? And then when that finally goes and happens and we sign in, although my web server isn't running, so it probably won't work very well. When we finally have that up and going, then you'll get your role data from Azure AD as opposed to getting it from your own database or wherever it might be. So I know we're coming up to time. So if there are any questions or anything, you can find me on Twitter. I'm on GitHub. I'll share out the link we'll share out the link on Twitter for all of the code that was shown today. And then if there are any questions, feel free to reach out. And thanks for coming.
Yeah, thank you everyone for joining us today. We really appreciate it. So I posted a couple of links on the chat window. One is for you to join the next series of calls for starting in 2020. And the other one, if you guys want to provide feedback or if you have ideas for future topics, we'd love to hear from you because that helps us figure out what topics you want to hear from. All right. Thank you, everyone. Thank you, John Patrick.